if you've been in the highway, and especially in the asphalt industry for long enough, you've probably already seen Dr. Epps talk, or heard of him at least, because he's with the Texas A&M Transportation Institute, often referred to as TTI. He's the Executive Associate Director and Senior Research Fellow there over the Pavement Materials and Construction Facilities Group. He's been in the industry for over 40 years, with 32 years of leadership positions at Texas A&M and University of Nevada, Reno. Has done research that's led to advancements in updated standards in pavement materials, including pavement maintenance and management systems, and pavement recycling and economics. Spent 10 years in the private sector at Granite Construction, and has served in leadership roles in state and national professional organizations. Got his bachelor's, master's, and PhD all at UC Berkeley, is that right? And as a licensed engineer in the state of Texas, going to talk about dispute resolution. Everyone welcome Dr. Epps.
I'll try to be a little bit specific here and there, but I'm not going to get down in the weeds too far, even though there's some slides that might imply that. So this is sort of the outline that I'm going to follow today, and we'll just go through this. Pavement preservation alternatives, there's some common disputes that are associated with these, and what kind of resolutions we end up with sometimes. So this is more or less the major topics of this conference that we're here at this week. Unfortunately, most of the data that I have, and I'm not saying that this data doesn't exist for the other forms of pavement preservation, but most of it's with the hot mix industry. If you really want to dig into a lot of things that go on with chip seals and slurry seals and fog seals, it's not there that I'm aware of. And it creates difficulties for us in terms of dispute resolution. I'll try to point those out. So 10 years in industry and a bunch of other years doing things in teaching, research, and other kinds of activities within the industry really leads me to these things that probably came up most frequently. And the comparison between quality control and quality assurance tests. If the specifications are set up where there's a group of quality control tests and a group of quality assurance tests, there are usually problems trying to get those two things to agree with each other unless there's not a lot of things done ahead of time. The job mix formula, most of the specifications today, well, not most, I guess most of them do, indicate that the contractor will supply the job mix formula for whatever material it may be, and the state will approve that. Originally, the state approved it by running companion tests, and then the problem started to arrive because you'd have one group running test over here, another group running test over here, different equipment, different labs, different people, and guess what? Different answers. So who's right, who's wrong? The solution to that has been largely, well, let's go ahead and have the contractor supply the mix design, and the state will do a paper review of that mix design and approve it mix design. That doesn't happen everywhere, but it's happened an awful lot to get rid of that dispute. It's not the right way to do it, but it's happened a fair amount in many states. Changing materials, most specifications in their specs indicate that if you change the asphalt binder, for example, or the aggregate, then you have to do a new mix design and go through the process again. And a lot of times what happens, and the contractor doesn't really have control of his materials at sometimes, the material supplier says, well, we got to change this because of 5 reasons, and you're trapped if you have to go through a new mix design. So then you try to evaluate, well, how serious is this, et cetera, et cetera. But those things have come up quite often in my look at the business. And then the ultimate one is we have premature distress. We never have failures on pavements. It's just premature distress out there. And that leads to all kinds of interesting conflicts that we have to look at. So here's something that I think that we put into place on some of our projects when I was in industry. Try to figure out where the risks are, where the high risks are before the job starts, associated with testing and evaluation of materials and mix designs, et cetera. And if those high risk areas, if you can find out who's going to be doing the sampling and testing, if it's the agency or a consultant for the project, get together ahead of time and see if you can't maybe exchange samples, do a mini round robin or something like that to see if you're getting the same results. And if you do that, it will save a lot of time later on. Now remember, before you start the project, there's no money involved. But as soon as you start the project and have a difference between quality control and quality assurance tests, for example, there's money involved and things become much more serious. So the idea is to head this off ahead of time. It involves the public agency, it involves the contractor, material suppliers, and other people that are involved in this. And you try to resolve these reoccurring issues. Again, you pretty well know what some of them are. Pre-construction meetings, pre-paving meetings, they really work well if they're conducted well. So all the people are on the same page, the quality management systems are in place, people know their roles and responsibilities. Some of our specifications aren't the best in the world. There's no perfect spec. I don't know of any. There's always room in there to wiggle a little bit, and it creates problems for us. And then you just can't have enough meetings and information exchange. Performance warranties, 1 year performance warranty. I don't know how many times I've read that in the specifications. I have no idea what performance warranty means. And so if you're going to write one, be as specific as you can and be able to interpret what you're saying. And this is the source of quite a few problems as well. After that, third parties get involved, then you have dispute resolutions and legal activities, and you really don't want to get down to the bottom part of this chart. It's not productive for anybody. So some key activities and measurements. Pre-construction, we'll sort of break it out a little bit. Take a look at what goes on in construction, post-construction that can lead to some disputes. And in the pre-construction, this is usually when the mixed design is performed. You have all these things going on there, as we've talked about today. I can't stress equipment calibration. I don't know how many projects I've been on where the asphalt distributor pulls up on the job and it obviously hasn't been looked at for 50 years. I think soon after it was bought. And it's just a major, major problem. On the other hand, some states have very rigorous requirements for their equipment. And the rigorous ones are almost, well, they are calibrated once a year. That's not good enough in many cases. And I noticed that maybe some states have an indication that they might want to check rock distribution rates, asphalt distribution rates for every job, which is probably a good idea if it's a real critical job, particularly when you're doing like chip seals under high traffic and volumes. You've got to get those things right. So equipment calibration is not performed as much as it should be. The contractor really has a responsibility here that they need to do it probably more frequently than what is called for in many, many specifications. I do believe in laboratory accreditation. I do believe in certification of technicians. Those two things are fundamental to what we do. And it looks like we're reaching out and getting those into the slurry seals, microsurfacing, and chip seal arena, which I really think is a good idea because we don't have a good handle on variability of the tests that we use there. In the construction, we sort of left out process control tests today. These are things that contractors do to control their material supplies and other kinds of things that they don't appear in the formal quality control, quality assurance arena required tests, but they could be and should be part of the quality management system. And they're a very important integral part of this thing, and they will help us understand when things go south on us a little bit. Talked about independent assurance tests already and the other things that are up there. Post-construction is all about getting paid and getting out of there, settle the job, don't have any problems associated with it. And final acceptance is very important. And then I did mention the performance warranty and major problems associated with some of those. Some of the warranty, extended warranty kinds of projects that I've looked at, if you look at what the warranty language is all about, I don't know who wrote it, but they didn't know a lot about pavements and construction. It's just poor. And it's not fair. It's not fair to the owner agency, and it's not fair to the contracting agency. So, job mix formula, how many times do we check the aggregate and asphalt binder rate on a chip seal project if we're putting it down out there? That's sort of a job mix formula. How often do we check it on a microsurfacing? Do we get samples of the materials, and do we check the emulsion contents and additive contents? How do we check that except from meters off of the roadway? How often do we check the aggregate requirements in terms of materials? We may check it during mix design, but once the project starts, it isn't often checked, the aggregate quality. I can recall Jim was involved in this. We were working on a large test track program out in Nevada, and I wrote into a national a specification that would be at least considered nationally about sampling and testing the aggregates once production started for hot mix on a regular basis, some frequency. And the thinking was that maybe the quality of the pit changes or the quarry or what have you, and it'd be a good idea to pick that up somewhere along the line. And it was unanimously thrown out by everybody there, including the agencies and the contractors. It's just something we don't do, and it makes the assumption that things don't change with time, and that's a false assumption. Mixture properties, that comes to quality control and quality assurance. Project selection. So when things go wrong, my favorite thing is, well, you told me to put that slurry seal on this project and it had alligator fatigue cracking, you expected it to last 10 years. And I'm saying, buddy, that ain't gonna happen. Well, then why'd you put it down there? Well, you told me to put it down there. So you get in this vicious discussion and it absolutely goes nowhere. So project selection, I just put it up there to remind us of that, but it has to do with project selection, pre-construction and construction, things all come together to look at performance issues that occur out there. My time in industry, I spent a lot of time fighting the variability game, and so I want to spend a few minutes on that. And I don't want to get too deep in the weeds here, but we get a bunch of variables that are involved in some of our quality control, quality assurance kinds of specs, and one of them is asphalt binder content on hot mixes. So a lot of the data you'll see here comes from that industry. And so we measure asphalt binder content, say, on 60 samples, and we plot them up on a bar chart, and we look at that and we say, well, I knew a mathematician one time that put a curve through there, and he has a nice ugly equation that fits that. And we measure standard deviation, and we get means, and then we plot them on charts like this, and they mean something to us. And if you're going to be in quality control, get to understand a normal distribution, a T distribution, what have you, mean standard deviations, what they mean, what these things look like, because it's really important to you. It'll help your company stay in business or go out of business, as the case may be. In this particular case, if you look at these two things, they have about the same variability in terms of standard deviation or variance. In fact, they do, and they have different mean values, where these samples here have all the same mean value, but they have a lot more variability in some cases than others, and you can tell that by the shape of the curves. So I would encourage you to get to that level of understanding of statistics. And let me tell you, when I was in undergraduate school, statistics was the last thing I wanted to learn. And remember, we had slide rules. We didn't have calculators or computers, and they really weren't a useful tool because you couldn't do all the calculations associated with it. So the modern era, which happened about 40 years ago or 30 years ago, allowed us to do a lot more with statistics, and the generation we have now can really do a lot with statistics. So pay attention when you're in undergraduate school, or get a graduate course or two under your belt. So it's important, understand it. And this is sort of one of my favorite equations. The variability associated with sampling and testing and measuring quality during construction are made up of these three major variables, which are really made up of a bunch of sub-variables even in this case. But just think about it. We have to go out there and sample it. Our sampling is not perfect. We have to run a test, and testing is not perfect, and we'll see that in just a minute. And then there are material variability and construction variabilities that occur on the project. Now, out of all three of these, which one affects performance? Which of these affects performance? Is it the total variability on the left side that affects variability and construction performance, or is it just one of the three? You measure sampling and testing variability every time you take a sample and test it. The only thing that affects performance is the variability associated with materials and construction. That's it. Everything else is along for the ride. So your job is to minimize those first two. And that's what we ought to be doing. We need to minimize those. The ugly part of this is that about 50% or 60% in some cases is associated with sampling and testing. The variability is that much of it. Sometimes it's only 30%. And actually, there's very few studies that I know about, even on hot mix, that identify what percent of the variability associated with a certain test is due to sampling and testing. Very few studies. And in microsurfacing and chip seals, there's practically none that I know of. So it's important to know what variability affects performance, because that's okay. If we do everything, I don't care about a quality management system. If every time I could produce a good job, one that performs, we're okay. But you can't do that. Can't do it. Sampling variability. Key lesson off of this, you don't need to study the table. The more samples you take, the more certainty you have around how much variability you have and what your true median value is or mean value is. And the risk becomes less to the owner and less to the contractor the more samples you take in general. And those are the takeaways from that, and that's very important. Second major thing about sampling is you need to use stratified and random samples to make sure that you get samples from all portion of your daily production or whatever your production sequence would be. It's very important that you do that. And the third point is that whatever your point of sampling is for asphalts or aggregates or whatever it may be, make sure that that point of sampling information database was used to develop your specification. I've seen a lot of specifications where you sampled here and the specification over here said you're going to sample somewhere else. And those data sets are not congruent and it doesn't work out and you have to fight through a few things on that. This was a situation just for aggregate gradation. I'm going to pull up here because of time. I didn't go over the last slide. But if you use cold feed samples or loose hot mix asphalt samples or cores from a project, you get different standard deviations or variability associated with sieve sizes for when you look at gradations. And this is actual data set. It's a pretty robust data set from the same test track that we built a number of years ago. So you don't always get the same variability depending upon the point of sampling. So it's important that you get that correct in the specifications. Testing variability. This has got small numbers on it, so don't worry about it. And this is the single operator precision. If you look at ASTM within laboratory precision, it means one person doing it in a single laboratory running asphalt, cement specific gravity or aggregate specific gravity to make it ever what it is. It's in within the lab, one person. And you look in these test methods, both in AASHTO and ASTM, and you get a sense of what the variability is associated primarily with just testing. However, some of the round robins are conducted where they introduce some sampling variability in there, so you need to be very careful of this. So you look at those numbers and you say, well, they're not very big and they don't mean anything, so you look at them again and it says the same thing. And then you say, well, what happens if I run the test in my lab and Mark runs it in his lab, then we got even more stuff going on. And that's the between or laboratory precision. And both of those things are extremely important to look at. And we did some things with those. We just said, well, to get the air void content in a hot mix, for example, you need the theoretical maximum specific gravity, which is identified as G sub mm on this plot, and you need the bulk specific gravity, G sub mb. And the previous chart showed you the precision and bias, standard deviations associated with those tests, and you put them into something called a Monte Carlo simulation, and you find out that your air voids can be a lot bigger than that. And it's surprising how big they can get. In fact, they get very large. And here's some of the summaries that could happen, rarely does, thank God. The variability can cause a lot of problems, and particularly volumetrics of hot mixes. It can also cause problems with gradations of aggregates. This has to do, again, with hot mix within laboratory, within a single laboratory now. Test method variability may lead to differences in air voids and voids of mineral aggregates of 1% for any given mix. That's just test variability, nothing else, nothing else. And these differences can translate into differences of 0.7% in asphalt binder content, which is huge. Doesn't happen very often, but it can be only test method variability, not sampling, not production kinds of things. And then if you get between laboratories, these numbers go up even more. You can get asphalt content differences that are in the order of 1%, as you can see here. And these are just certain kinds of mixes under certain kinds of situation, but it does happen. Materials and construction variability, again, maybe you're only measuring 50% of what's important on a project in terms of performance, but that's an important 50%. You try to, again, get so your materials and construction variability is really the important thing, and you reduce your sampling and testing variability every way you do it, and you do it for accreditation of your laboratories and get your testing personnel accredited, certified, whatever the word may be in your state, and that's a step in the right direction. I just pulled up some typical variability for hot mixes here. It's surprising what these numbers are sometime. If you have a hot mix operation, take these numbers back, and if you're higher than this, ask yourself why. If you're lower than that, ask yourself why as well, because if it's a lot lower than that, maybe you're not truthful with yourself. But these are just representative. We're looking at a lot of state data. This is just a representative value, but should be somewhere in that range there. So why understand testing variability? Well, we want to provide a quality product to our customer. We think if it's consistent, has low variability, it's going to be a better product, particularly if it's on the target values for the mix designs, et cetera, and it will be. You want to remain in business. If you're out of specification too often, your variability is too high, you're not going to be in business today. So it's extremely important for those of you that are in the business. And you want to use these values to establish specification limits, and the specification limits should be based on what the contractors are capable of doing, not what you think they ought to do, because that won't work. If the contractors cannot meet the variability that you have in your limits, if you get enough of them in that situation, they're going to complain, and there's going to be politics involved in it, and some of the politics you don't want to be involved in. And then you can also use these Monte Carlo simulations to predict pay factors if you have that kind of a specification. So knowing your variability of your production, et cetera. And this is where the percent within limit specs come in. There's just a couple of examples here that show you that. Since time is short, we'll go to the summary. For fog seals, how often do you actually test the transverse distribution of your fog seal or tack coat? Could be longitudinal distribution of it. Well, we sprayed this many feet and it's about that wide, and the tank says we use that much, or the meter says. We rarely do it. It's something that ought to be done. Variability of the surface also has to do with it. Slurry seal microsurfacing. I don't know how many times we actually looked at the uniformity of distribution transversely and longitudinally along a project. Probably not often. Nor did we take materials from the slurry seal machine off the roadway and run gradations and binder contents. Some companies do that religiously, and I applaud them for doing that. Same thing with chip seals, as I just talked about for the other materials. In the asphalt mixtures, it's thin overlays, mixed design, mixed properties. In-place properties are important. It's hard for us to do that. And then you need to make sure that your individual properties are certainly the ones that you use in your mixed design as well. So resolution, back to that. Let's go over this again, and because I think it's really pretty important here. It's best to identify reoccurring problems that you've had on typical kinds of projects ahead of time, and get together before the project starts with the agency or owner in charge of that, and particularly their laboratory that they're going to use and the laboratory personnel, and exchange samples that were prepared identically the same and see where your issues are going to be. For FAA specifications, which are really difficult to meet, we've done that on a number of jobs and it worked out well for us. A lot of times consultants, laboratories, or it could be a state laboratory, but you need to get that done. And if there's one takeaway, I would highly recommend that you do that. Make sure that you're sampling at the same location. Make sure your variabilities historically have been about the same. And look at the specifications. Sometimes there are specifications written that are unreasonable, particularly city-county specs. They'll have asphalt binder content has to be plus or minus 0.2% off of the design value, and you can't do that. You can't make it in the long run. You're going to be out of spec 60-70% of the time at least, probably. Make sure the specifications are clear. If they're not clear, try to get the language cleaned up ahead of time. Have meetings ahead of the project. You're certainly going to have meetings during the project. Then you have to go to partial pay on some projects if it's not part of the specification. We've offered performance warranties in some cases when we thought there was a good product down out there and it would meet some kind of a warranty spec, taking a risk, taking a chance on that rather than saying remove it and replace it. And then arbitration and legal, and certainly everybody goes through that, and you don't want to go there. Nobody's going to win usually in that case. Remember, time is money. The worst thing you want to hear out there as a contractor is remove and replace. Certainly, there's no question about that. And the time is money bit is getting test results back, resolving issues quickly. If you change materials, trying to get those things resolved very quickly in terms of mixed designs. And ultimately, again, this is the bottom line, the owner has to be satisfied. Absolutely, totally, that's where you get down to. Any questions? That is not a mountain in Texas, by the way. Wish it was. The other question was how much quality assurance, quality control do you want to have on things like fog seals, or even for that matter, chip seals and slurry seals, because there's not a lot today. And right now, I don't think we have enough personally. I don't think we have enough. And I think it starts with the equipment calibration as we talked about. It's got to be there. The material certifications have got to be there, some system to assure that the materials are right. And then after that, if as an agency, if you go ahead and measure longitudinal and transverse distribution a few times out there and have that threat hanging there, you'll probably see some improvement in what's going on, and whether it be slurry or chips or other kinds of treatments. And it's always up to the owner to sample and test as frequently as they want to. It should always be that way. It's a matter if you want to execute it or not. But the equipment calibration and fogs and slurries and chips is extremely important, and the materials are less important, but the calibration of the equipment is just, has to be there. Thank you very much. It's yours.